Welcome to Networks Professionals.
All right, let's just dive right in and look at the invisible engine that is literally shaping our modern world. Welcome to today's Explainer. We're going to push past all the usual buzzwords and break down exactly how artificial intelligence operates under the hood, focusing on one huge concept: deep learning. Because, what's actually powering your phone's face unlock? Or those crazy smart chatbots? Or even self-driving cars navigating complex city streets? Sometimes it honestly feels like pure magic, right? But it's not. It's a highly specific, immensely powerful branch of computer science.
Section 1. Meet Deep Learning. Beyond Basic Machine Learning.
So, deep learning is actually a specialized subset of machine learning. It uses artificial neural networks packed with, deep layers to analyze incredibly complex, high-dimensional data. Basically, we're stepping way beyond broad machine learning into architectures designed to handle just massive, incredibly dense information. And get this, the number 3 is kind of the magic threshold here. The word deep isn't just slick marketing speak. It literally refers to the number of layers in these neural networks. 3 or more layers officially makes it deep learning, though actually some of the most advanced models out there today have hundreds of layers stacked together. It's wild. Section 2. Under the hood. The layers and how data travels. Think of this as a quick little journey. Step 1, the input layer receives the raw data, like the pixels of a photograph, for example. Then, step 2, the data moves into the hidden layers. This is the real deep processing core where the heavy lifting, the actual calculating and analyzing happens. And finally, step 3, the output layer delivers the result, telling you that yes, the photo is in fact a dog. Raw input, straight to smart output. Section 3, the secret. Automatic feature extraction, the leap in technology. Now, this is where the massive leap really happens. With traditional machine learning, humans had to manually point out features. Engineers literally had to code the computer to look for specific shapes or edges. But deep learning totally flips the script. It autonomously learns the most important features all on its own. It figures out what makes a stop sign look like a stop sign, completely by itself. No hand-holding required. But, there is a catch. To unlock all that autonomous genius, it needs fuel. Deep learning absolutely requires vast, almost unfathomable amounts of data to actually achieve high accuracy. Sure, it frequently outperforms us humans, but only if it's fed millions of data points to learn from. Without an absolute ocean of data, the engine just won't run.
Section 4. Deep Learning in Daily Life, where we experience it. And you are interacting with this constantly, probably without even noticing. Image recognition? Yep, that's deep learning mapping your face to unlock your phone, or an autonomous car spotting a pedestrian. Natural language processing? That's the engine behind your real-time translation tools and those incredibly fluent AI text generators. And hey, every time your favorite streaming app miraculously knows exactly what show you want to binge next, a deep learning recommendation system is absolutely pulling the strings. Section 5. The Blueprints. From CNNs to GANs, mapping the architectures. Let's just quickly match the technical architecture to its real-world superpower so the acronyms don't feel so intimidating. First up, CNNs, convolutional neural networks. These are your visual processors, totally excelling at image analysis. Next, RNNs and LSTMs. Their superpower? Handling sequential data, which makes them the absolute masterminds behind processing human speech and audio over time. And finally, GANs, generative adversarial networks. Their superpower is pure creation, generating completely original synthetic images and audio just out of thin air. So ultimately, deep learning is serving as the absolutely indispensable engine behind modern artificial intelligence. Whenever a task requires recognizing vastly complex patterns, whether it's spotting a tiny anomaly in an MRI scan or making sense of human language, deep learning is the core technology that's making it happen. Which leaves us with one pretty massive defining question. If deep learning is already outperforming humans in these highly specific, complex tasks today, what invisible patterns is it going to uncover next? As we feed these networks more data and build even deeper architectures, the possibilities are just staggering. Thanks for joining me for this explainer. Keep learning, keep questioning, and I'll catch you next time.
Thanks for watching.